as Fused, which was first introduced in its past this year to simulate intermittent computing. Now, Fused stands for Full System Simulation of Energy-Driven Computing. Fused can simulate the execution of compiled binaries at the cycle level and includes a power model that is readily adaptable to this work. Since then, we have extended Fused such that it can now simulate an entire wireless sensor node class device. Shades of gray in this diagram indicates extensions in this work. We added models for on-chip peripherals, such as SPI for on-chip onboard communication, and external peripherals and circuitry, like the power management circuitry and the harvesters, as well as sensors and radio modules. We also include in the code repository drivers and software stacks. At the time of writing this paper, the radio channel emulator shown here um, simply dumps the physical layer packets onto the console, or standard output. It includes the payload and metadata about the packet. The modules in Fused are written in System C and C++, and we take advantage of the analog mixed signal extensions to System C in this work for the power delivery circuitry. A word about a power model. So in Fused, active components such as the microcontroller, and the radio module and sensors would log events and states. Now, these events and states are used by the power estimator, the current estimator, to generate a current load on the power delivery circuitry. This sets the operating points of various electrical components along the power delivery path, and this, for example, will determine the efficiency of the power converters. So here is an example of a full virtual prototype of an entire system that's captured and fused. This is a solar-powered ambient sensor node, which includes the NRF radio module, a BME280 ambient sensor, and an MSP microcontroller, among other stuff. On the power delivery path, there are monitors and power converters and the solar cell. We can simulate such a system in Fused and get traces like one shown here. In this case, we have a simple piece of C code that is loaded onto the memory model of the virtual prototype and executed for 14 milliseconds.